Hello, everyone. Today we'll talk about Sassy. This is an updated version from the version that I created in August 2022. I think that needs an upgrade. Also, I've got a new audio gear, so hopefully the voice quality will be much better. Now, understand about Sassy, we have to first understand about the history of how network security and network technology has evolved. So, I remember that when internet started, we were using the dial-up line. So there was a modem that would dial up to an ISP like BSNL in those days, and I would get internet connection. So this was a very slow connection. There were hardly any websites available. And then as technology evolved, we started getting dedicated lines, fiber, 4, 2G, 3G, and 4G and 5G, right? On the network security side, uh, the most basic control that any company deployed was enterprise firewalls. Okay, essentially, what a firewall would do is it would inspect any packet coming and going out of your network. It would try to decrypt it. It will look at any known intrusion signatures and block if any known signature or patterns are coming. It would also look at what applications are uh, browsed by your end users, as well as it will do URL filtering, which is ensuring that the traffic doesn't go to any malicious known URLs. Okay, so this is I'm talking in context of the modern next generation firewalls, which know what applications are. They understand if it is your Microsoft Teams or Zoom's running, or it's somebody browsing the website using a browser. Okay. Also on the network side, when from the corporate point of view, a very common uh, structure, and it still exists today for a lot of large organizations, is that they would have a central headquarter and lot of branch offices, and all the users sitting in the branch. Example, let's take any top bank of our country. What Each branch would get an internet connection, and this, whenever they are browsing, this traffic will go to the headquarters network, and from there it will go to internet. So they were trying to control everything. They were monitoring what users were doing, and they were providing security. Okay, and end users were all were working in this hub and spoke manner. Okay, the problem was that it slowed down their end user experience, because let's say there is a bigger branch out of a large city where number of employees are much higher. They will send more traffic compared to a smaller branch, but because there was one point of uh, internet access, all users will not get good experience, because it is getting traffic from the same source, or the inspection is happening at the same place. Now, as world evolved, more technology came addressing specific use case, like people who wanted to work from home. So virtual private networks or VPN came, and NAC, which restricted people uh, about devices that they can put up on the network, IPS, which is about a pattern recognition to identify known attacks, sandboxing, which is a simulation technology where files can be executed, and their maliciousness verdict can be checked, and they can be blocked if they are malicious for the system. DDoS technologies that would control incoming DOS attacks, DLP, which would monitor for any outbound sensitive content and would alert the user or block that uh, data loss, WAF, which would monitor specific attacks related to web applications, and endpoint security, which would monitor endpoints or desktops and laptops that we are using for any malicious activity. Okay, so these technologies, and there are more and more and more. Okay, so cybersecurity, as I've said in my introduction videos, and I'll put up a link to it, uh, is that there are around 5 to 6 thousand companies in cybersecurity across 15 domain, maybe 20, not more than that, and they're trying to solve the same problems using their own approaches. Okay. Then, as world evolved, SWG or Secure Web Gateway came in. This is an added layer where there is more monitoring and filtering done on the web traffic, which is what you are browsing from your internet uh, browser. So Uh, Take example of your home Wi-Fi, right? What happens is whenever you are browsing, there is your from your device like a mobile or your system, the traffic it goes to your router. From right router, it goes to your internet service provider, and then there to the internet. There is no intermediate uh, watching security unless you have something available in the your Wi-Fi router. Like my Wi-Fi router comes with a firewall. Okay. Now SWG is essentially a product or a tool uh, that would monitor this web traffic. It would look at the kind of application that you're browsing. It will keep a note of it. It will see if those domains or URLs are known good, known bad. It will block if it is known bad. It will look at malware presence in that traffic. You can control type of traffic that goes out from your browser. It will decrypt and look at the content going within that traffic, and it will also inspect the outbound traffic for known sensitive data patterns. Okay, so this is what a SWG uh, delivers. Then came CASB. CASB is another layer on top of SWG, which is more focused on application governance, which means it keeps track of what applications are getting browsed by your end users. Are they approved? What kind of actions they can perform in it? Is this application containing malicious data or non-sensitive data for the DLP use case? It will also perform analytics in terms of user activity, uh, who are the top users who are browsing the most malicious website, uh, top applications, etc. So it's more about the security governance of or governance of the application world. And the reason it is called cloud access and also a broker, because typically this technology was provided as a cloud service. I'll come to that later. But what happened is, historically there was always a hardware loaded with a software that was taking care of a specific use case. So whenever there was a problem that the companies wanted to solve, they would buy this product from a software vendor, also known as OEM, original equipment manufacturer. They would buy this software or they would buy this software or a hardware. If it is software, they will get their own server, install that software on their own hardware. Then they will also check damages if during the shipping process, if it can switch on, there is no damage, and they can eventually rack it. And then once they configure it by assigning network address, etc., and creating administrative users, the administrators would log in and create policies. These administrators will typically be trained on the product that they are working on. Okay. Now, while so example of firewall is a good old technology, mostly that was used on in the networks as a hardware appliance. Okay. So if you look at all top firewall manufacturers, they would provide a hardware with a loaded operating system and an application. They would have given a different name to these operating systems. Some cases the operating system are customized to be more secure, more stable, and for better performance. Now, once the product is in operations, typically administrators of that product will maintain the hardware, essentially ensuring that the disk is not full, memory is properly utilized, there are no performance bottleneck. Hardware, in case it goes down, let's say disk fails, how to replace it, how to also after a few years, as you know, hardware needs upgradation. Technology is evolving at a very fast pace, so they will buy new hardware, okay, which offers better and faster performance. So this is always an ongoing cycle. Okay. Now, as time evolved, some of these use cases started to come up as services, which means corporates who wanted to use these products don't need to buy this hardware. What the software OEM will do is they will put these capabilities in their data centers. So the enterprise or the organization can do is they can just redirect the traffic to the OEM's data center, and they don't need to buy any hardware, which is good, right? A lot of operations work is gone, and they can just focus on administration. It started with proxy, to my understanding. If I remember correctly, 2007, 2008, I know about companies who are in that business. Some of them don't exist anymore. While this was happening, the security, the cloud world or CSPs, cloud service providers, got evolved. Companies like Microsoft, Amazon, AWS, they started coming in, and they would provide all these uh, data center capabilities, which means OEMs don't need to build their own data centers. Uh, Microsoft, AWS, or Google, they were getting good business on this. They were focused on ensuring that the data centers and the softwares that are needed by data centers are easily usable by anyone, including organizations who are using the product as well as the organizations who are making the product. So cybersecurity software manufacturer, and similarly in other industries, what happened is they started using these CSPs. I'll give you a recent example. One of the reasons Microsoft has invested in Chat GPT because of the need of compute. Chat GPT infrastructure would need thousands and thousands of servers to run, uh, and who will provide that? Of course, Microsoft will provide that. Okay, so uh, this helps Microsoft, this helps Chat GPT, right? So it's a win-win for both the businesses. Now, uh, as businesses don't need to manage their software, they can just focus on policies and monitoring. This increased productivity. As you can imagine, I don't have to worry about hardware getting delivered or hardware getting end of life. Okay, now summary: most products that were traditionally available as hardware are today available as a SaaS, or as an application which is running in third parties data center. Okay, hardware based appliances still exist. This because of the need from various organizations who are doing it for because of regulations, compliance, nature of business. Example: governments typically don't want to host data in cloud service providers infrastructure because they're not sure about the data, they don't trust them, and they can't control security. Uh, because in case of CSPs, you as an organization are responsible for end-to-end security, and hence these specific industries or sectors don't want to use the CSPs, and hence will always be there, okay, for data privacy, data security reasons. Now, while cybersecurity was evolving from a traditional hardware model to a more SaaS oriented model, network was also evolving. SD-WAN, software defined WAN networks, new connection types, 4G, 5G came, network stability, speed increased. I don't, at least in where I live, I don't experience much downtime coming from these internet providers. And even if it does, the system has become smart enough to find out outages. It creates a ticket on its own, and engineers are called only when the issues are there. Good old days, there would be a lineman available for each of the region or an area, and they would be called if there is an issue. There was no automation or monitoring involved. The focus is now towards user experience and application performance improvement. That's what is happening as an end user or at the corporate level. So network has also evolved along with the network technology that's powering the network. Okay, now what is SASE? So SASE is essentially a SaaS based security capability. So this is a diagram from Gartner, uh, and what this talks about on the left hand side is WAN services as well as security services. So SASE is essentially a convergence of modern WAN capabilities, modern network capabilities to simplify it, as well as this SSE part, which is security capabilities that are provided in a SaaS form factor, not hardware, uh, and they are very easy to use. Now, what is eventually happening is any entities, so whether they're employees, contractor, partners, or devices, mobile users, etc., they can connect to the corporate resources anywhere. So these resources can be applications, data, devices, etc. Uh, I can be anywhere and I can access my company's infrastructure in a zero trust manner. Call it more secure manner. I'll do an episode on zero trust network sometime later. And what this infrastructure or SASE provides is a integrated capability. Now, also there are two things in this. SASE contains WAN edge services and SSE, Security Services Edge. I have seen confusion in the industry where even cybersecurity experts confuse SASE with SSE. SSE is rather a new term which just focuses on the security use case of offered from cloud, and WAN, and whereas WAN is considered separately. But SASE essentially means a single capability. Now today, not many companies offer this from their cloud. It is still evolving. Top companies in the world are still building it. So the future is not far. I would say it's almost here, where from the same application you would be able to manage your network as well as define security use cases. Okay, so that's what SASE is. It's a cloud uh, managed security services capability as well as network services capability. Okay. Now, if you have questions beyond this on specific use case, I'll be happy to do another video. Watch out more videos on cybersecurity basics, why you should talk about it. I know there are layoffs coming, and there are everyone is talking about it. But in cybersecurity, we still need more people. Okay, because it is a priority for every company to ensure that the uh, security is there no matter where the enterprise business is. Now, how you can learn SASE? So SASE is a way to deliver the software, right? Basics won't change. So learn about basics of cyber security, which includes firewalls, SWG, CASB, etc. Uh, Start with traditional stuff, and as you build basics, you will learn more. Okay. So anybody who knows hardware firewalls can easily learn SASE. There's nothing special about it except new capabilities. So instead of having 10 different products and 10 different appliances, SASE offers everything in a single console. So that's how it helps you. Okay. With that, thank you so much. Thank you for watching this video. I hope I'm able to produce great content and it helps you in your career. Thank you so much. Keep learning.